Okay, this video is for people who would like to see a binomial expansion problem, a challenging binomial expansion problem done slowly so that you could take it all in. I am going to do problem 2I from page 1, which is 2x minus 1 over x, quantity to the fourth power. First thing you want to do a binomial expansion problem is you want to have access to Pascal's triangle, and you can just do one in the corner every time you do a test or something so that you have it all ready. Remember that the way you construct Pascal's triangle is you take each one of the numbers that are next to each other and you use them to generate a new number, which would be those two numbers added together. So, for example, the 3 and the 1 here would become 4. And the rest of them are pretty easy to do, except for the ones at the edges. Maybe you're like, well, what do I do with the 1 here? Well, just imagine that the left and the right are filled with zeros, and you add the 0 and the 1, and you get 1. Okay? So basically, you can do this forever. But obviously, you don't want to do more than like maybe the 7th or 8th row. Eventually, you start getting like big sums that are maybe harder to do. But basically, for numbers where the power is like 5 to 10, you could do it with Pascal's triangle if you're going to expand it completely. Okay, and if you're going to do a problem where they only ask you for one of the terms of the binomial expansion, if you don't know what that means yet, just ignore me for now. Then you can use an alternative method, but if they ask you to expand the whole thing, you might as well do Pascal's triangle. So in this case, we're going to look at what the problem is that they gave us, and we're going to see that the power for the binomial expansion is 4, so that means you can come down here to Pascal's triangle and you can identify that it would be this row. How do you know it's this row? Because in the second term, you have the 4 there, so that means it's to the power of 4. Okay? So, next thing you're going to do whenever you have a binomial expansion problem is you're going to make a little train. The train is going to look like this. It's going to be like square, triangle, circle, plus square, triangle, circle, plus square, triangle, circle, plus square, triangle, circle, plus. How long do you need to go on? Well, it turns out that the number of terms in a binomial expansion is 1 more than the power. So it would be 4 plus 1. It would be 5 terms. Okay, so I need 5 terms. I have 1, 2, 3, 4, and I need 1 more. So I'm going to put 1 more here. Okay, and then inside each one of these shapes, I am going to put some information. And let me just like try to make this all fit into one line so it's a little easier to see. Oops. Okay. Now, inside each one of these squares, I am going to put my Pascal's triangle coefficient. If you remember, for the 4 n equals 4 row, when I say n equals 4, I'm talking about the power. It's 1, 4, 6, 4, 1. So I'm going to put 1, 4, 6, 4, 1 in the squares. 1, 4, 6, 4, and 1. Okay? One of the reasons why I drew shapes here is to also substitute for parentheses. Okay? So imagine that every one of these shapes, you can consider that basically you have parentheses around whatever's inside the shape. Okay? The other thing that I drew these shapes for is to represent different parts of the binomial expansion. Okay, so if you look at a binomial expansion, it's called binomial because it has 2 terms in it. Okay, so you're taking a binomial, and which are 2 terms added or subtracted together, and you are going to multiply it times itself this many times, and you're going to get a whole bunch of terms. When you get a whole bunch of terms, basically what you're going to do is you're going to repeat the pattern of the first term and the second term in a specific way. And the way that pattern looks is kind of like this little train I made with squares, triangles, and circles. Okay, first thing, the first term is the triangle term. The second term is the circle term. And you notice I also circled the negative sign because you do want to include the negative sign together with the second term. Okay? And not only that, but when you make this little train with the square, triangle, and circle, each one of the triangles and circles has a power associated with it. Okay? And there's a pattern with the power. The powers are increasing or decreasing. And for the triangles, we are going to start with the same power that's in the binomial expansion, and we're going to make that the power for the first triangle. And then we're going to decrease by 1 every time. So the triangle starts at 4, and look, it goes to 0, doesn't it? The circle term, which is the second term, is going to start with the opposite end. So it's going to start with 0, which is a little bit tricky because you might think it starts with 1, but it starts with 0. And then it counts up to 4. Okay? And then now what you're going to do is the easiest part, which is you are going to copy down the triangle information into each one of the triangles. You're going to copy the circle information into all the circles. And then you're pretty much done, believe it or not. So the triangle information, and like if you look at a traditional explanation of how to do this, they are going to define the first term as A and the second term as B. Okay? And so basically what you're doing is you substitute in for A 2x and you substitute in for B -1/x. But I think it's kind of tricky sometimes because sometimes inside your binomial you have A and B. And then to substitute A and B into A and B, but it's not exactly A and B, is kind of mind-boggling, so I use the shapes. Okay, so in every triangle, I'm going to write 2x. And I'm going to do it in red just so that you can see a little bit more clearly that all I'm doing is repeating the first term many times. How many times? Turns out I'm repeating it 5 times, right? 5 times because it's 1 more than 4. Okay, next I'm going to take the second term, which is 1/x, and I'm going to make that green. 1/x. Actually, it's -1/x, right? Because it's got a negative sign there, and I want to keep the negative sign together with the term because then you don't need to like account for it in another way, which might be kind of hard to remember. So if you ever have a negative sign, whether it be leading the triangle or leading the circle, go ahead and keep that negative sign together with the expression you're filling in to the triangle or the circle. Okay? Now what I'm going to do is I am going to make my life a little bit easier by remembering that anything to the 0 power is 1. So I am going to eliminate this term and this term because they're to the 0 power, which means it's just 1, so it's like they don't exist, right? So that made my life a little bit easier. Now what I'm going to do is I'm going to recopy everything, and I'm going to recopy it, and I'm going to put it in parentheses instead of in shapes, just to remind you that each one of these shapes means that you can put parentheses around it so that we can make the multiplication clearer. So the first one is going to be 1 times 2x to the 4th. The second one is going to be 4 times 2x cubed -1/x to the 1st. Then I have 6 2x squared. And then I have -1/x squared. Then I have plus 4 2x to the 1st -1/x cubed. And then for the last one, I have 1 -1/x to the 4th, right? Okay. Now, I can make my life a little easier by eliminating the 1s, right? Because 1s multiplied times anything is just whatever it's multiplied times. So it's the same thing as not having it, right? And then I could look through and I could see, okay, what are the effect of these negative signs? If I have negatives, and they're inside a parentheses, and that expression inside the parentheses is to the 1st power, then the negative is going to stay, okay? What if I have -1/x to the 2nd power? If I have like -2 squared, that's equal to negative 2 times negative 2, which is equal to positive 4. So the negative is like it wasn't there, right? Negative 2 squared is the same thing as positive 2 squared. So when is it that the negative inside the parentheses actually makes a difference? Well, when the negative happens to be in an odd numbered power. So if I have negative 2 to the first, or I have negative 2 cubed, then it's going to make a difference. Negative 2 to the first is negative 2. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. Okay? So you can see that it makes a difference if you have an odd power or if you have an even power. The negative is going to stay or it's going to cancel itself out, right? Okay, so knowing that, let's change it so that instead of having the negatives inside each one of these, we could take it out if it's still going to exist. Okay, so let's see. This one here, the negative is still going to exist, okay, because it's odd power. It's to the first, right? So I'm going to put the negative sign out here. This one here, no, because the negative is inside squared, so it's going to become a positive. It's just going to be plus instead of the negative, right? This one here is to the odd power, so it's going to become negative also. And this one here is to an even power, so no, it's just going to be plus. Okay, now I'm going to copy everything down again, and I'm going to put 2x to the fourth, 4, I didn't put 4 in parentheses, but you can see that like putting the coefficients in parentheses is kind of overkill because the coefficients are always just, you know, numbers. So I could actually take those out of the parentheses if I wanted to. And now I'm just going to write everything without minus signs because I put the negatives out front now, right? Oops. And finally, okay. Now I am going to do the most difficult part. It's the part that a lot of people have trouble with because it's an algebra thing and some people don't remember the algebra too well. Whenever you have an algebra expression and you have everything in the parentheses and it's to a power, you actually have to distribute that power to everything separately inside the parentheses. And that's true if two things are multiplied together. It's also true if things are divided. So if I have this would actually be 2 to the fourth times x to the fourth. So it would actually be 16x to the fourth. Now if you have 1 over x squared, that's actually equal to 1 squared divided by x squared, which is actually equal to 1 over x squared, right? The 1 squared is just 1. Okay? So be careful with this step because this is the one that a lot of people make mistakes on. It's a real shame on a binomial expansion problem to make these kind of mistakes and get everything else right because you lose actually an extra point just by the fact that you didn't get the right answer at the end. So the first one's going to be 2 to the fourth x to the fourth minus 4 times 2 cubed x cubed. And then this one's going to be 1 over x to the first, okay, which is same as 1 over x. 6, 2 squared x squared, 1 over x squared, 4 times 2x times 1 over x cubed plus 1 over x to the fourth. Okay. Now, if you have x cubed over x, can you figure out that that's x squared? If you have x squared divided by x squared, can you figure out that that's x to the 0, which is equal to 1? The way you might do it if you can't figure that out is write them in negative exponents. So x to the first in the denominator, remember, is x to the negative 1. X squared in the denominator is x to the negative 2. Now you can use your exponent rules to add those exponents together and you get x squared, or you add those exponents together and you get x 0. Okay? I don't know which one's easier for you, but you got to know one or the other. Okay, now I'm going to simplify one last time. 2 to the fourth, x to the fourth is 16x to the fourth, because 2 times 2 times 2 times 2 is 16. 4 times 2 cubed is 8. 4 times 8 is 32. X cubed divided by x to the first is x squared. 6 times 2 squared is 24. X squared divided by x squared is 1. 4 times 2 is 8. X divided by x cubed is x squared. And last one is plus 1 over x to the fourth. And that's it. So there's a couple weird things about this one. First of all, the plus and the minus signs, do you see how like the first one's plus, second one's minus, third one's plus, fourth one's minus, and the last one's plus? So it turns out that whenever you have problems like this where either the triangle term or the circle term are negative, then you are going to get alternating signs like this, plus, minus, kind of like that. So like it's easy to check at the end if you did everything right, because you'll see that pattern. The other thing that's kind of different is the fact that like normally at the end you have like the constant term where you have a number and there's no variables multiplied times it. Do you see how the constant term in this particular problem ended up in the middle, the 24? And the reason why, of course, is because the triangle term contributed with an x in the numerator. The circle term contributed with an x in the denominator. They like, depending on the term, they kind of cancel each other out. So you ended up with the constant term without any variables in the middle of the thing. Okay? Not always going to end up in the middle. What if I had x squared in the triangle term and I had 1 over x in the circle term? I'm going to end up with the constant term in a weird place. Okay? And we'll do problems like that too later. But if you understood everything in this video, then you can do a lot of the problems that they're going to present to you on the exam. Probably half the problems, okay? It's not that hard, right? It's just got a few steps. There's some tricky things, such as if you get a negative circle value, or if you have x's in the denominator. There's certain things that they can do to make it tricky for you, but otherwise it's pretty much a procedure, right?